Hello and welcome to Warmup 1.03. All right, let's see what we got here. Does eating a delicious bowl of hearty, stomach-pleasing oatmeal reduce cholesterol? A marketer included the following graph as proof that the answer was most definitely yes. How is the graph misleading? What should be done to represent a more accurate picture of the situation? All right, so this is hitting on the concept of the area principle. And this graph is misleading because of the scale. All right. If we visually look at this, it looks like cholesterol is being cut in half or more. All right. It probably looks like it's being cut in half about right here. And then it's getting cut in half again down here. So, like, it's looking like it's a dramatic improvement. If we look at the scale, we see that the picture is actually a little more nuanced. All right. We're going from 209 down to 199. Which is good. I mean, you're dropping your cholesterol by 10 points, but the visual makes it look like it's being dropped by much, much more, which violates the area principle. So how is the graph misleading? It violates the area principle because the scale starts at 196. Instead, you should start scale at 0. So the size of the bars relates to their magnitude. And you probably don't need this last detail, as long as you just know that the scale should be starting at 0 so that the area and the relative magnitude of those bars are sort of reflective of one another. All right. But basically, understand that that violates the area principle, and we have to make sure that the area that the graphs are taking up corresponds to their values. All right. At the time this survey was taken, portable MP3 music players were super neat. I don't even know, like, are you guys too young for like just straight like iPods? Was music already on phones by the time you rolled around? I'm not even sure. Here are the percent of people in each group that claim to own one of these devices. If you had a ruler, a compass, and a protractor and a lot of time, could you make a pie chart with this information? Why or why not? All right, so here's the first thing people usually do. They say, oh, 44 plus 27 is 6471, plus 19 is 8190. 98, 100. Oh, yeah, they add up to 100. I'm totally good. I can make a pie chart. Not actually the case. All right, you have to make sure you're paying attention to what this information is actually conveying. What this is saying is in the group to 12 to 17, 44% of the people own an MP3 player, which means 56 do not. 56% do not. All right. 18 to 24, 27% own an MP3 player, which means that 73% do not. A pie chart usually compares a piece to the whole, but these numbers are not sort of comparing one to another. This isn't saying that out of all MP3 players, 44% are owned by this age group, 27% are owned by this age group, 19% are owned by this age group. You have to be careful and see what the chart is actually telling you. All right, so we could not make a single pie chart but we could make 5 pie charts, one for each group. All right, so it's just making sure that you're taking a close look at what the data actually is saying, and not just fall into that trap of, oh, these add up to 100, so we're good to go. Nope. You have to read the sentence. You have to analyze what's going on and make sure that you're handling it appropriately. So again, we could do this sort of pie graph. This could be the 12 to 17 pie graph, and we could say that 44% are yes and 56% are no, and then do the same thing for like 18 to 24, and say that like, oh, 27% are yes and 73% are no, but we can't actually put these into one pie chart because it's not all MP3 owners. Each one of these numbers is referring to just a separate group, and a pie chart's always the part to the whole. So it doesn't work going down, but we could go across and make each one of these a separate one. All right, let's take a look at the back. Here are the data on the percent of people in several age groups who attended a cinematic feature in the last 12 months. So we know this wasn't recently because theaters have not been open in the last 12 months. All right, a young hotshot movie studio executive is hoping to use this data to make millions of dollars. The executive wants to know what percent of the total audience is 18 to 24 years old. Will our ambitious executive be able to get the answer from this data? Why or why not? All right. So if this is the only data that they have, then no, there's nothing they can do to transform this into the percent of 18 to 24 from the total audience. If you knew that each of these groups were the same size, you could calculate that information. If you knew the relative size of each of these groups, like, oh, this group included, 10 million people, and this group included 5 million people, and this group included 4 million people, then you could sort of do those calculations. But without that sort of information, our studio executive is not actually going to be is actually going to be able to answer their question, and they're probably not going to make their millions of dollars, and they're probably going to be really sad, and that's unfortunate, but that's what they get for being bad at statistics. So they will not be able to answer that question because they don't know the size of each of the age groups. So again, yes, a lot of 18 to 24-year-olds attended movies, but if that's a really small age group, it might not matter. They might be a small percentage of your overall customer base. 75 years and older, maybe only 20% of them attended movies, but if it's a giant group, that 20% could actually make up a large part of your audience. So again, without knowing the size of these groups, this information isn't enough to tell us the breakdown of the overall audience, right? We'd have to know the size of these age groups to do that. So again, data tells a story. You're trying to pull information from that data, but sometimes you have the wrong data, right, to answer the questions that you want to have. And that's kind of what I was talking about earlier with like designing surveys. When you gather your data, it's important that you know what questions you want to answer, because if you don't know the questions you want to answer, you might find yourself with the wrong data, and then you're kind of stuck. All right, so it's important to kind of have all those things in your head before you start. All right, last but not least, email spam is the curse of the internet, though possibly more tolerable than actual spam. I'm not going to comment. Maybe there's some spam fans on the internet. Personally, not my thing. Here's a breakdown of the most common types of spam: adult, financial, health, internet, leisure, products, scams, which I don't understand how that's a separate category, and then other. So what percent of spam would fall into the other category? If someone wants to be able to compare the relative size of each category, what would be a better choice, a pie chart or a bar chart, and why? So remember, a pie chart is always comparing the part to the whole. So if we've got all these categories, they should add up to 100%. So if this is 20 and this is 19, that's 39, that's 46, that's 53, that's 59, that's 79, 84, that's 93. So that should tell us that 7% is left over in that other category. So what percent of spam would fall into the other category? Other would be 7%. So that we're looking at the whole. That's the full 100%. And then if we're comparing the relative size of each category, all right, that's generally going to be a bar chart is better for comparing relative size, comma, a pie chart is better at comparing a part to the whole. And again, I mean, it's pretty easily to like just do a quick example that illustrates that. If I just made this random pie chart, it can be difficult to tell, you know, is this section the same size as this section? Is this section the same size as this section? Versus a bar chart, it's much easier to say, oh, okay, I can see that these are close, but this is a little lower. Or, oh, this one's way bigger than the other ones, and it's much easier to compare. So if you're just comparing the individual categories, you want to use a bar chart. If you're comparing one part to everything else, then it's easier to use a pie chart. So it's just choosing the right tool for the information that you're trying to convey. All right. So hopefully this was helpful, and good luck with the notes. Bye.